Hello everyone. All right, so today we are going to be talking about basically everything that has to do with angles, all right? And in doing that, we're going to talk about how to convert between degrees, which is probably your more familiar angle measure, and radians. We are going to talk about what it means to be complementary and supplementary. And lastly, we're going to talk about arc length. All right, so those are the three things. So once we get through all those three things, you'll know that our video for today is done. All right, so without further ado, we're going to start by talking about how to convert between degrees and radians. Now, you should have already had an activity that talked about what a radian is. All right, that's that ratio around the circle with relation to the radius. That's why it's a radian. And so in that, you should have learned that 2 pi, which is one turn around the circle in radians, is equal to our more familiar measure of 360 degrees. Okay? Now, when we go to convert, we're going to convert looking at what we have, and we're going to multiply by 1. But that 1 is going to look a little different. We're either going to take this fraction, or this equation that we know to be true, and we're going to take the 360 and divide it by 2 pi, which means we're going to get 180 over pi. And so whenever you have an angle that's already in radians, because it has a pi symbol in it, you're going to multiply it by 180 degrees over pi, and that will get you degrees. Okay? So, if we take that same conversion, this ratio that we know to be true, and we write it the other way, so if we write it as 2 pi over 360, that reduces down to pi over 180. So if you notice, it's the same basic fractions, just in one, the 180's on the top, and one of them, the 180's on the bottom. And so when we look at this, what we want to think about is anytime we have a degree measure, we're going to multiply by pi over 180 degrees, and that's going to get us our radians. Okay, so radians times 180 degrees times pi over 180. Okay, so what does this even look like? Well, I'm going to show you a few examples to kind of help you see what I'm talking about. All right, so it's important for you to assess what kind of angle you have. So right now in this first problem, I have an angle that's in degrees, and I can tell because it has that degree symbol. So what we're going to do is we're going to take 45 degrees, and we're going to multiply it by, I want to convert this to the other form, so I want to convert this to radians. So I'm going to multiply this by pi over 180. Okay, and the reason why you want to have the 180 in the bottom, I don't necessarily remember both of these things separately. I just remember the fraction, and I think I want to cancel the degrees out because one's in the top of this fraction and one's in the bottom. And then you want to reduce this fraction. So we're going to write it as 45 pi over 180. You want to reduce this part of the fraction, the part with the 45 and the 180. So you have to ask yourself, what do those have in common? Well, they're definitely both divisible by 5. Maybe 180 is divisible by 45, so you might have to do a little math in your head. Hopefully you end up figuring out that, yes, 45 goes into 180, so this is actually pi, like 1 pi, over 4. And that's going to be your answer. And then if you get an angle that's in radians, and the way that we know that this is in radians is because you see the pi for sure, okay? Or basically, anytime something doesn't have a degree symbol, it's in radians. So we're going to take this and we're going to multiply it by 180 degrees over pi. So I flip the fraction because now I want the pi's to cancel instead of the degrees. And so then I get 180 degrees over 9. And I look at this and I go, 18 divided by 9 is 2, so this must be 20 degrees. All right, now I want you to try these next two on your own. and come back and see the answer. All right, hopefully you got 10 pi for this next one, and then negative 70 degrees for that last one. If you need to pause so you can see the work, go ahead. Now, these next two I left for us to talk about because there's no degree symbol, but yet there's no pi symbol. These are still radians, okay? If you see a whole number without any degree symbol, then we're talking about something that's in radians or decimal. Basically, an easier way to remember this is if there's no degree symbol. Let me write that down. So if you forget that degree symbol, we're going to assume you wrote it in radians. Okay, so what does that mean? That means you're actually going to have to take negative 2 times 180 over pi. And you're actually going to have to do this one on your calculator. So I'm going to write these two out. 3.6 times 180 over pi. And you're going to need to get your calculator out and figure out those values. And we're going to approximate those. We're probably going to approximate to 3 decimal places. So take a second and try that out. And when you come back, the answers will be there. All right, folks, so you should have gotten negative 114.592 degrees and positive 206.265 degrees. All right, moving on to a definite topic that should be reviewed are these two definitions of what it means to be complementary and what it means to be supplementary. Okay, so two positive angles are complementary if their sum is 90 degrees or negative 90 degrees, and or pi over 2. Where am I getting that? Well, I've just converted 90 degrees to pi over 2. Okay, that's the radian version of 90 degrees. And then two positive angles are supplementary. Hopefully you remember that that's 180 degrees, or in radian terms, that would be pi. So what we're going to do is we're going to look at a couple of examples and see if we can figure out their complement and their supplement. Now, just so you know, complements and supplements don't have to share a common side, and also there doesn't necessarily have to be a supplement to everything, because some angles are bigger than 180 degrees, or I'm sorry, bigger than 90. Anyway, so if we have a 40-degree angle, what would the complement be? That complement would be 50 degrees, because 40 plus 50 gets you to 90. And then 40 plus 140 degrees, that would get you your supplement. Now what about here? Is there an angle you could add to 150 that would get you to 90? Yes, if you did a negative angle, but they have to have the same sign. So they need to be the same sign and have the same direction. So none. No complement exists. Supplement would be 30 degrees. All right? So these next few are in radians. So you may need to kind of think about, is this greater or less than pi over 2 as you're doing, each of them. All right? I'm going to give you a chance to try these out. All right, so hopefully you got none for the complement of A and B, with a supplement of pi over 4 to make this 4 over 4 so that it's 1 pi. And same thing here with 11 pi over 12, none for the complement, but 1/12 would get you to 12 over 12, which would make this 1 pi, since a supplement should be 180 degrees or pi, so equal to pi. This last one I figured might be a little tricky. So pi over 2 is that 90. That's where we decide whether or not we get a complement. And pi over 2, well, pi is a number. Pi divided by 2 is 1.57-ish. So this number is bigger than 2 is bigger than 1.57, so there's no complement here either. But there is a supplement, and that we can just say is pi, which is 180 degrees, minus 2. We're just going to leave it like that, whatever that difference is. Okay? So there's a few more practice problems here. Again, I'm going to pause and let you guys try and figure out the complement or supplement depending on what it's asking you for. These first 3 are asking you for a complement, the next 3 a supplement. All right, welcome back. Here are your answers to your complements and supplements. I figured we might need to talk a little about how you would think about number 1 and number 3, so I'm just going to talk through that for a second. So if you've got an angle and you want to figure out how it adds up to be complementary, you want to think about that angle plus something would equal pi over 2. Well, remember that this is like a fraction of 1/2. Well, we could think of that fraction, if we change that common denominator, as 2/4. Well, if I already have 1/4 and I need to get to 2/4, I'm just going to add another fourth. And then over here, same idea, only we'd have to make sure we get a common denominator for both of these. So we would change this to 2/6, and we would change this to 3/6. And how do we get from 2/6 to 3/6? We need another 6. All right, so I'm getting a common denominator to help me figure that out. And then at the bottom, I think we already did number 4, so that one should have been pretty easy for us. All right, last topic for us to talk about today is arc length. Okay, so first off, what is an arc? Well, luckily for me, I've got the ability to draw myself a nice circle, so I'm going to use that. So an arc is any distance along the curve of our circle. All right, that is an arc. Okay, and we call the length of that arc, we call it S. Okay, and so from the center of a circle to that arc, we can look at a radius and some angle theta. Okay, now in geometry or in your previous math life, you may have seen this arc length formula as 2 pi r times theta over 360. But you know something now that you didn't know then, which is that 2 pi and 360 are equivalent. So they cancel each other out. So our formula for arc length is that the arc length is just equal to, if you look at what I have left here, the radius times theta. So that's the radius, and that's our angle. That's this 0 with the like parallel line through it, like one line straight through it, is called theta. Angle, and it's going to need to be in radians. That is a must that that angle is in radians. Okay, and so just to remind you what this symbol is theta. It is the Greek letter used to represent an angle. You are going to see that symbol so much this semester, it's going to be crazy. Okay, and I forgot to put one other little word here. This is the central angle. Yeah, it can't just be any angle. It has to be an angle that is located at the center. All right, so we're going to do maybe one or two practice problems. So suppose here, I'm going to write this formula down, S equals R times theta. Okay, suppose like in problem number 1, you're actually looking for theta. Well, you would plug in this information. So S is 4, the radius is 4, and we don't know theta. So we're just going to solve for theta. So it looks like theta is going to be equal to 1. And if you want to write the word radian, you can, or rad. That's all right too. Sometimes you're going to be given an angle, but it won't be in radians, so you're going to have to convert it. And I would definitely get used to converting it, okay? Get used to writing your angles in radians. So if I want to find the arc length, this is S here. That means I'm going to take that radius that's over here, 9, times pi over 3. And for that answer above this little line, I'm going to get 3 pi, and then I need to double check my units, which are feet. All right? So just keep working on these, and then in a few moments, I'll show you the answers to 1 through 5, and then I'll show you the answers to 6 through 9. All right, folks, here are your answers for the first 5 questions, and this last one should be 30 pi centimeters. All right, so pause that if you need to take a second. All right, ladies and gents, these are your last couple of answers. 16 pi over 3 in meters. 40 over pi feet. You could also round that to 3 decimal places if you want to divide by the pi. And then I did that for these last 2 just to see what that looks like. But then you have to should put this little like approximate equal squiggle. So we get 7.639 inches and 3.993 miles. Thanks so much. All right, we'll see you back here real soon. Bye, folks.